So today we're looking at offsetting roof trusses. So if you look at the image above here, and you looked at the height, for example, and you cut it in half, or you cut it, you'll notice that it can't be cut in half. So if I redraw this triangle and you cut it down from the height, it's no longer cut in half. So we can't do SOHCAHTOA anymore because I don't know what the length is from here to here versus from here to here. So you got to look at the triangle holistically, the whole triangle. So let's just look at the span is 24 feet 6 inches. So let's just convert that right away to just inches. So 24 times 12 plus 6, we have 294 inches. So that's my span. And then we have pitches of 25 degrees and 30 degrees. And so if I label this, say A, B, C, you could solve for this angle right here, angle B, by doing 180, which is the sum of all interior angles. So you know all three angles have to add up to 180. So angle B would be 180 degrees, subtract what 25 plus 30 work out to. So that's a 55. So 180 minus 55 would be the angle of the top, so the vertical angle. So 125 degrees. So that's the vertical angle up here. And so the way this works is angles are capital letters. So you see capital A, B, C. And then across from it would be the same letter but lowercase. So the span would be B. This rafter length would be called A, and this rafter length would be C. So remember, these are rafter lengths here. So that's what you're solving for, rafter length and rafter length. So you're going to do this question twice. Now, because you're not working with a right triangle, you are no longer doing SOHCAHTOA, you're using Sine Law. So if you need to, go back to your trig formulas, so over here, and you're going to scroll down a little bit further down. So here was SOHCAHTOA. So that's for right triangles. We're not doing right triangles, so you got to go further down and you're going to work with this. So you could see how it's A over sine A equals B over sine B equals C over sine C. Never write all three down. You're only going to do two fractions at a time. So I'm going to solve for the B's first. So you're going to do matching mates. So basically I'm doing this guy. So those are my B's. Okay, so I have all the B's. So B is a 294 with angle 125 degrees. So then I will solve the A's. So I'm going to do that matching. So when you set up your proportion, you're going to set it up as little a over sine 25, because a with a equals b 294 over sine 125. Now, you can do one of two things. You can cross multiply right away and start working with it. I prefer actually to rewrite the left side. So I'm going to rewrite a over sine 25. And I'm going to work out the right side. So I'm going to, in my calculator, go 294 divided by sine of 125 equals. And so that's 358.9077. And I'm going to put that over 1. And now I'm going to cross multiply. It just makes it a lot easier to work with. So if I just cross multiply now, then all I'm doing is the 358.9077, and I'm going to multiply that with sine 25. And so that's 151.68096 inches. So now you're doing the question again, and I'm going to solve for the other rafter length, so the C's. but I'm going to reuse the b's. So you're going to have c over sine, and the angle C was 30 right here. So sine 30 equals, and I'm just going to rewrite the b's. So it was 294 over sine 125. Now I already know the answer of 294 divided by sine 125. So I'm just going to rewrite C over sine 30, and I'm going to write the 358.9077 over 1, and then I'm going to cross multiply. So 358.9077 times sine 30 equals 179.4539 inches. Okay, and then for number 2, you're just converting those two rafter lengths to feet inches. So just use your staircase method.